I'm looking at question 11.3 from Webassign, and in this question, it's asking you to determine the shape around the designated atom. So, for example, if we're looking at part A here, let's look at number 1. Okay, this carbon atom here. So it's asking for its shape. And the way we can determine this is based on the number of groups that's around it. Now, there's a table in your text. It's table 11.1, and it's on page 376. I'm assuming you have the third edition of the text. So, and here, I'm going to refer to this, and you'll find it very useful. And on this table, it's going to literally, let me do this pull down. It's going to show the different. It's going to define what's linear, trigonal planar, tetrahedral, trigonal pyramidal, and bent. And it's simply based on the number of groups that are around that atom. Now, the way they do it is they take and they say, hey, you count the number of atoms or lone pairs. And in this case, there's no lone pairs here. So they would just simply say this carbon has one hydrogen, a second hydrogen, and another carbon. It has 3 atoms attached to it. I would like to stick to what I said in class. Instead of calling them atoms, let's look at the number of sigma bonds around it. And it's the same thing, since there's always a sigma bond attached to the atom on the other end. But it really it works out better for us, and we'll see why later. So using that same logic, you have this carbon. You got one sigma bond here, one sigma bond here. Now you have a double bond here, and like I said in class, a double bond, there's 2 bonds. One is a sigma and one is a pi. So we ignore the pi bond, just the sigma bond. So there's 3 sigma bonds around this, or 3 groups of electrons around it. So now if you go to table 11.1 from your text, you'll see in that column for total number of groups, we have 3 groups of electrons, and that would then correspond to trigonal planar. Okay. Let's take a look at this one here, number 6. So here you have a carbon atom again. If we look at the number of sigma bonds, you got 1 sigma bond here, 1 here. You also have, again, a double bond, but only 1 sigma bond that is present in this double bond. So a total of 3 groups of electrons. So lo and behold, it would be trigonal planar. Okay, so now let's look at, just choose one. Here, number 5. Okay, so for number 5 here, we're pointing to an oxygen. Now remember, in the question, it alerts you, says, don't forget to consider electron pairs. So when I drew these, I didn't draw the structures, but it's assumed you know the appropriate number of lone pairs that should be on any atom. In this case, oxygen would have 2 lone pairs of electrons, so keep that in mind. Okay, so you got 1 sigma bond here, another sigma bond, that's 2, and each lone pair counts as a group of electrons, so you have a total of 4 groups of electrons, okay, that are on this atom, oxygen. So now if you go to table 11.1, you'll see that when you go to that column, you'll see there's 3 choices for 4 groups of electrons, and you're going to want to select, it'll be the bottom row where it's, in this case, where the 4 group has 2 lone pairs of electrons and then 2 atoms attached. Okay, and then this, we would say, would have the bent structure. Okay, now once you have these structures, then you actually know the approximate bond angles. So I have another, question 11 for asking for bond angles. So if you can assign the trigonal, the geometry around the atom, you got the bond angles, because the bond angles are also given in table 11.1. Okay, so one last one. Let's quickly look at 9 and. Let's see, I mislabeled. I said 5. Wait, let's see, let me correct this. Question 5 we said was bent. Okay, there. Okay. Now, did I make any other silly mistakes? Okay, good. Now, let's look at number 9. Number 9 here, carbon atom. You got 1 sigma bond here. You got a triple bond. A triple bond consists of, like I said in lecture, 1 sigma bond and 2 pi bonds. We only count the sigma bonds. So 1 sigma bond here, 1 here, total 2 sigma bonds. Thus, if you go to table 11.1 from your text, you'll see then that 2 groups are going to be linear. Okay, so truly done. Okay, hope you find this helpful.